Hello, my dear friends. I hope the video and audio is clear. Anyone is in live? Anyone is in live? Is the video and audio is clear? Anyone is in live? Is the video and audio is clear? Good evening, Satvik. Good evening. Good evening, Anime Boy. Good evening. Is the video and audio is clear? Yes, yes. Hi, Joshita. Good evening. Good evening, Shailaja. Good evening, Akshara. Right. Oh, yes. Video and audio is clear now. Right. Wait. No. Yeah. No. Now in the last class, I think we have done. Good evening, Sri Vaishnavi. Good evening, Vaishnavi. Good evening. Good evening. Good evening. Right. Now let me minimize my video so that we'll start the class. Good evening, Amit Dubey. Good evening. గుడ్ ఈవినింగ్ విష్ణుతేజ. గుడ్ మార్నింగ్. రైట్. నాయనా, ఇంకా నువ్వు స్కూల్లోనే ఉన్నావా? కాలేజీలో ఉన్నావా? కాలేజీ నుంచి పడుకొని లేవలేదా? ఈవినింగ్కి మార్నింగ్కి తేడా తెలుస్తలే. గుడ్ ఈవినింగ్ జైన్. గుడ్ మార్నింగ్. వావ్. గుడ్ మార్నింగ్. గుడ్ మార్నింగ్, గుడ్ ఈవినింగ్కి చాలా డిఫరెన్స్ ఉంది నాన్న. చాలా డిఫరెన్స్ ఉంది. గుడ్ మార్నింగ్కి గుడ్ ఈవినింగ్కి చాలా డిఫరెన్స్ ఉంది. సో మై డియర్ ఫ్రెండ్స్, రైట్. Now, the last class we have did up to where? Up to the which formulas we have done? Now we have done the formula up to. Can anyone say me up to which formula we have done? I think so. We have done RPS. Up to the RPS we have done. I think so. Now today we are going to see the which one? Total energy. Total energy formula we are going to see. Then after the total energy, then we are going to see the line spectra. Sir, the oxidation state and the CL and alcohol. Zainab, you are from like total energy. Good evening, Safal Chaturvedi. And the oxidation state and the covalency of AL in alcohol. Zainab, I was not understanding what you are trying to say. Safal Chaturvedi, good evening. No. Okay, right. The good evening, Vrunda. Good evening. Now, right. Now, the last class we have seen the formulas up to total energy and all. Now, today we are going to see the last class we have seen the. Now we have did the one question also based on that question. Sai Vaishnavi, good evening. Good evening, Sai Vaishnavi. Good evening. Good evening. Right. Almost the 5 minutes has been done. Now we'll see the next type of the formula that we are going to see, that is total energy. What we are having, that is total energy. Now, what is the meaning of the total energy? My dear friends who are in the live, beautiful BPC and MPC as well as the next MSET people, now try to be focused on the class. If you are having any concern, try to ask me, and the number of questions which I was giving, it will be helpful for you in the upcoming exams also. Clear? Done? For the beautiful BPC, they are having the 45 questions, and the GEMS JEE, they are having the 25 questions, and the excellent MSET, they are having the 40 questions. So I will do the number of questions. If you know the answer, try to give the answer. If not, what to do? Give the question mark. Clear? Done? These concepts are very important for your upcoming exams also. Oxidation state and the covalency is different. Al can form the 6 bonds, but oxidation state of the Al it is +3. Sign of the oxidation state and the covalency is not same. Nitrogen, the oxidation state is 3, but its covalency is 4. Okay, now what is the meaning of the total energy? Total energy is nothing but, here when the electron, if it is revolving in the orbit, now this electron is having the two types of energy. One, if the electron, this nucleus to this electron, it is having the potential energy when that electron is stopped. Now when it is revolving, it is having the kinetic energy. Clear? Now here we are having the one formula. Total energy is equal to potential energy plus kinetic energy. Potential energy plus kinetic energy we are having. My dear friend, the question which you have sent, it is not clear. Try to send it in a clear manner so that I can answer. Zainab. Now here potential energy. Now how the potential energy we are having? Now the electrostatic potential energy formula we know, right? Potential energy will be developed with the which one? One positive charge and one electric charge. Clear? Now the potential energy, here we are having the two charges, Q1, Q2. What? Q1 if it is a positive charge and the Q2 if it is a negative charge. Done. Now what is the charge of this nucleus? Charge of the nucleus is plus Zd. Here how many protons are there? That much is the nucleus charge, and the electron is a negative charge. Now here the K, because electron is a negative charge, right? So minus K Z E square by R. Is it clear how this formula came? Because due to the one positive charge nucleus and the negatively charged electron is negative charge and the nucleus is a positive charge, and how much it is having the charge means how many protons are there, that many positive charges will be there. So Ze, and the negative, right? Positive into negative, you will get the negative. So the potential energy is equal to minus K Z square by R. Done? Clear? Now next, kinetic energy. Kinetic energy formula we know, half mv square. Done? Clear? Now here the half. Now in the place of the mv square, now can we write in this manner? Here the electrostatic force of attraction K ZE square R square is equal to mv square by R. Done? This is a which one? Electrostatic force of attraction will be equal to the centrifugal force. Yesterday I was explained very clearly. Done? Now you see here which is cancelled, R and R is cancelled. Then mv square is equal to K Z E square by R. Can I write? Can I write like this? Now this kz square can I substitute here? Kinetic energy is equal to half kz e square by r. Kz e square by r. Now the total energy. Now the kinetic energy formula we got this one, and the potential energy formula we got this one. Now if we put it in the which one? Total energy formula. Total energy is equal to potential energy, right? Potential energy k z e square by r plus half k z e square by r. Then if you solve this one, now what you will get? Total energy is equal to k z e square by 2r. K z e square by 2r. Clear? Now next one, the total energy formula by putting the all the values here. Here the total energy En is equal to minus k z e square by 2r. Now the R is equal to minus k z e square 2, and the radius of an orbit n square we are having n square h square by 4 pi square m z k e square. Clear? This we are having the R. Now if you substitute all the values, now what are the variables we are having? Only the variables we are having z, n square and z. Clear? Now that it will get minus 13.6 into z square by n square electron volt. Now this is the total energy formula we are having. Clear? Next, if they ask you in the which one? Joules. We know 1 joule is equal to, sorry, 1 electron volt. 1 electron volt in the joule is equal to 1.6 into 10 to the power minus 19 joule, right? Clear? Now then the formula will become 2.8 minus 2.18 into 10 to the power minus 18 z square by n square into joule. If they are asking in the joule, use this formula. If they are asking in the electron volt, use this formula. Clear? Now we'll calculate the energy. Now may I know what is the energy of the ground state when the electron is present in E is equal to 1? May I know what is the energy of that electron or energy of that orbit? The electron is present in N is equal to 1. Now what is the energy it is having? What is the energy? How much energy that electron it is having? That hydrogen like atom, if it is present in the N is equal to 1 orbit, how much energy it is having? My dear students, beautiful BPC as well as excellent MSET and the GEMS JEE. Now minus 13.6. Good. Now the beautiful BPC students are saying fast. Yes. Hi Rex, hi. Sai Vaishnavi minus 13.6. Akshara minus 13.6. Joshita. Now the first as said by the Amit Dubey from the NEET, right? Now here the minus 13. Here it is a minus 13.6 electron volt. Now if the electron, if it is present in N is equal to 2. Now what is the energy? E is equal to 2. Now when the electron is present in N is equal to the orbit, what is the energy? And when the electron is present in N is equal to 4, and what is the energy? Can anyone say me? Now minus 13.6, then after that minus 13.6, then after that what is the energies we are having? Minus 3.4 electron volt. Next, minus 1.51 electron volt. Yes, yes, good, good, Amit Dubey, good. Minus 0.85 electron volt. Clear? Right. Shailaja. Yes. Clear? Now these are the electron volts we are having. Now here to here the energy is increasing. Now if the electron, if it is present in the ground state, yes, good. Now my question, here this is a nucleus and these are the orbit. Now if the electron is present in the n is equal to 1 orbit, now good, Akshara good, Sai Vaishnavi good, Shailaja, Joshita good. Now here my question now. Oh, okay. Subhana, good, Subhana, good. Right. Now, my dear friends, good. Right. Right. Now, my dear friends, now my question for you is, now if the electron when it is in the ground state, now this electron to excite to the n is equal to 2 orbit. This electron when it is present in the ground state to excite to the n is equal to 2 orbit, how much energy it should absorb? This electron to excite to the n is equal to 2 orbit, how much energy it should be absorbed? This electron, if it is want to go from the n is equal to 1 orbit to the n is equal to 2 orbit, yes, it should absorb the plus 10.2 electron volt, it should be absorbed. Clear? Now, this electron to excite from the lower energy state to the lower ground state to the first excited state. Now this we call it as a, which one, how much energy it should absorb? Plus 10.2 electron volt it should be absorbed. Done. Then again it should come to the ground state. How much? Good evening Vishnu, good evening. Now to come to the ground state, how much energy it should lose? It should lose the minus 10.2 electron volt, it should lose, so that it will reach to the ground state. Clear? Right. Now here, right. Now the change in energy will be calculated by the E final minus E initial. Clear? Now the E final means n is equal to infinity. E final, if the electron, if it is went into the higher excited state, if we say, means E final is nothing but E infinity. Now if the electron when it is want to make it to the E infinity, how much energy I was to supply? If I want to make the electron ionized, how much energy I was to supply? If I want to make the electron ionized, here this is a nucleus, electron I want to send it into the n is equal to infinity or n is equal to infinity state. How much energy I was to supply? This n is, Rohan Reddy sir, do you teach any educational institute? Yes. I used to teach in one college. That's the reason. Yes, Rohan, I used to teach in college. College come the tuition institution. That is. Now, here this electron to be get ionized from the n is equal to 1 orbit. This electron to get n is equal to or ionized to the n is equal to 1 orbit. Now how much energy I was to supply? This electron is having the minus 13.6 electron volt, right? Now to make this electron's energy 0, then how much energy I was to supply? If I supply plus 13.6 electron volt, if I supply, this electron's energy will become 0, right? So it will be excited to the which one? N is equal to infinity orbit. So by that, if I want to make the any atom ionized in the sense, if I want to make the electron or if I want to send it that electron to the n is equal to infinity orbit, now I was to supply as good. plus 13.6 electron volt. Then the ionization energy formula we got it as plus 13.6 into Z square by N square electron volt. Plus 13.6 into Z square by N square electron volt. This is very, very important. Clear? Done. Now, the next type of the concept this next we are going to see, that is, which is the next concept that we are going to see. If the electron, if it is present in n is equal to 1 orbit, now by giving the energy to this orbit, now or this electron which is present in the n is equal to 1 orbit, it will absorb that energy and it will be excited to the higher excited state. Now in the higher excited state, electron is stable or unstable? In the higher excited state, electron is stable or unstable? In the higher excited state, electron is stable or unstable? Can anyone? Here the electron, it is a minus 13.6 electron volt in the ground state. This one we say it as a ground state. Now this is a n is equal to 2. Now this energy is minus 3. It is unstable. In the higher energy state, now in the higher energy state, that electron is unstable. Now this one we call it as a first excited state. This is one we call it as a first excited state. Right? Now the electron is unstable in the higher excited state. What it will happen? Again it will comes to the lower energy state. While coming the lower energy state, now whatever the energy it has been absorbed, it should be re-emit back. That re-emitted radiation is falling under the different region. Due to that we got the different line spectrum. Due to that we got the different line spectrum, and that type of the spectrum we call it as a emission spectrum or line spectrum. Now by that we got the one formula, that is emission spectrum. That one we got the formula, that is emission spectrum. Clear? Right. Emission spectrum. What is the meaning of the emission spectrum or the line spectrum of the hydrogen atom? Now the excited electron, excited state electron re-emits, clear? Re-emits the radiation when it coming back to the ground state. When it is coming to the ground state, it will re-emit that energy. That re-emitted energy will falling under the different region. Now by that, who has given for that one? We got the analysis from the emission spectrum. When that see, if I was taking the one hydrogen atom, now hydrogen atom, when I was giving certain energy, now it has excited to the some higher energy level. Which energy level it has excited, we don't know. But when it is coming from the higher energy level to the lower energy level, it is emitting some radiation. That emitted radiation we are studying. That one they have given on the basis of formula delta E is equal to E2 minus E1. Now energy difference will be calculated on the basis of this formula only, right? Now based on this formula, I was not deriving any formula here. It is not at all important derivation. Just formula is important for us. Clear? Now the direct formula we got from this one, that is wave number is equal to 1 by lambda, that we know. That will be equal to the Rydberg constant into z square by 1 by n1 square minus 1 by n2 square. Clear? Now here, what is the n1 here and what is the n2 here? Can anyone? What is the n1 here and what is the n2 here? What is the n1 and what is the n2 here? What is the n1 and what is the n2? What is the n1 and what is the n2? What is the n1 and what is the n2? What is the N1 and what is the N2? What is the N1 and what is the N2? What is the N1 and what is the N2? Here, what is the N1 and what is the N2? No, no, no. I'm not asking that one. Joshita. No, no, no. I'm asking which one is the lower energy level, which one is the higher energy level. Good, Subhana, good, 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 Amma. Joshita, you have tried. I was asking, N1 is no, enemy boy, N1 is lower, N1 is lower energy level, and N2 is higher. Excited state orbital. Good, good, good. These are lower energy level and the higher energy level. Lower energy level as well as higher energy level. Yes, yes, yes. Good, good, good. Good, good, Subhana. Good. Right. And the next one, another important formula we are having, that is very important formula, that is lambda is equal to 912 angstroms by z square into 1 by n1 square by 1 by n2 square. Clear? If we use this formula, now we can calculate now in the which lines that excited electron, when it is coming from the excited state to the ground state, it is falling, we can calculate. Yes, 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 right. Now here, now 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 we are going to see the how the line spectra as came. Now how the line spectra as came, now we are going to see. Now this is a nucleus, now the electron is in the ground state. Now when the electron, this hydrogen atom, it is in the one spectrum type. Clear? Yes, 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 good, good, good. Now this is, we are having the one hydrogen atom. Now in this hydrogen gas, it is there, we are passing the some radiation. Now this hydrogen gas, it has converted to the hydrogen atom, and this hydrogen atom, it is having one electron. That electron, its energy it has absorbed, it has excited to the higher energy state. While it is coming back, it is emitting some radiation. That emitted radiation, as collectively they have studied and given the some lines. Now what are that lines we are going to see right now? If electron, the from the n is equal to infinity, from n is equal to infinity means higher energy level, that is electron by absorbing some energy, which infinity or which energy level it has went, we don't know. So we think that now electron, assume that electron has went to up to the infinity and it is coming to the ground state. When the electron is coming from the n is equal to infinity to ground state, and that type of the lines we will call it as a which one? Lyman. That type of the lines we call it as a Lyman. Clear? Now if the n is equal to 2, if it is falling, if n is equal to 2, if it is coming from n is equal to 3, if it is coming from n is equal to 4, now if it is coming from n is equal to 5, let's suppose if it is coming from n is equal to 6, right? Now right. Next is bomber. Yes, yes, good, good, good. Mohan, good. Mohan, Abhinay, good. Now the first one, first line, when it is coming from the infinity to 1, that type of the lines we call it as a Lyman. Now the second line here, now 6 to, next 5, next 4, next 3, next 2. Clear? Now these are the lines of the which one? Of Lyman series. Now the next lines of the which series? Next line we are having, when it is coming from the first line. See. Now the next from the bomber series, here the lines are coming. or the second line. Okay. Now in this manner the lines will come. Yes, yes. Now the third line will be, now the third line, now the third type of the lines we call it as a, which one? Third type of the lines we call it as a fashion. Now when the electrons are coming and when it is falling from the, okay, right. Right. Yes, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, and n is equal to infinity. Right? Done. Now here to here. Now this series we call it as a, which one? Balmer series. Next one, this one we call it as a fashion. Clear? Next one, this is a fashion. Next one, this is a bracket. Done. Now this one is a P fund. Clear? This one is a P fund. And the last one is a Humphrey. Last one, if suppose if the electron, if it is coming from the n is equal to 6, last one it is a Humphrey. Good. Right. Sixth one is a Humphrey. Right. Now here we are going to calculate now the first line of the Lyman. First line of Lyman. Here we are going to calculate the first line of the Lyman. What is the first line of the Lyman? From where to where the first line of the Lyman? N2 to N1. What is the N2 and what is the N1 for the Lyman? And next, second line of the Lyman. Next, second line of Lyman. Second line of Lyman. From N2 to which one? N1. Now, last line of Lyman. From where to where these lines will come? From where to where? From where to where? Good, Joshita, good. Now N2 to N1 is the first line. Now second line will be, second line of the Lyman will be, good, Akshara, good. Now second line of the Lyman will be, from where to where? Second line of the Lyman will be from where to where? Good, Nana, good. Second line of the Lyman will be 3 to 1. Second line of the Lyman will be 3 to 1. Yes. Next, last line of the Lyman will be? Last line of the Lyman will be? Last line of the Lyman will be? Good, Nana, good. Subhana, good. Last line of the Lyman will be? Last line of the Lyman will be, right, good. Infinity to 1. Infinity to 1. This is a last line of the Lyman. Right? This is the last line of the Lyman. Now, right. Okay. Now we'll calculate. Yes. Right. Now we'll calculate the which one? Now, in which wavelength that first line of the Lyman, or which region it is falling. Now the lambda for UV region. For the UV region, now the lambda will be from the 400 to almost 4000 angstroms. Okay. Next, lambda for visible region is from the 4000 to 7500 angstroms. Clear? Next, lambda for IR region, lambda for the IR region is greater than 7500 angstroms. Clear? This, if you remember, now in which regions these lines are falling, we can calculate. On the basis of which one? On the basis of which one? Now the one formula I was given, right? For the Lyman series, first line of the Lyman we are calculating. First line of Lyman. First line of the Lyman will be from the n is equal to 2 to n is equal to 1. Now here we are having the portion for you senior advance for the Monday is alcohols, phenols, ethers completely. Alcohol, phenols and ethers. Alcohols, phenols, ethers. This is the portion for your Monday exam. Right. Okay. Right. Now here the first line of the Lyman will be calculated on the basis of lambda is equal to 912 angstroms by z square into 1 by okay no 1 by n1 square minus 1 by n2 square. Clear? Now 912 angstroms for the hydrogen atom it is 1. Now n1 is a 1 and the n2 is a 4 because 2 square it will become 4. Then if you cross multiply the lambda will get 912 by 4 by not 4 3 by 4, right? How much you will get? You will get almost 3 by 4. You will get 3 by 4. If you calculate 912 into 4 by 3 approx you will get how much you will get, Nana? This one lambda how much you will get? Lambda how much you will get? First line of the Lyman series how much you will get? How much you will get the first line of the Lyman? How much you will get? How much you will get the first line of the Lyman? How much is the first line of the Lyman you are getting? How much is the first line of Lyman you are getting? How much you are getting, Nana? No, right. Good. Now 1216 angstroms you are getting. Good. Good, Nana. Right. Now 1216 line is in between the UV region, right? It is between the UV region. So this line's first line and the last line. First line is 212 angstroms and the last line is 912 angstroms. So it is between the UV region, right? So the all the Lyman series region it will falls in the UV. Now if you calculate for the Bohr series what it will happen? Only the first few lines, only the first 4 lines will comes under the visible. Only the first 4 lines will comes under the visible region and the remaining all will be the go to the UV region. Clear? Done. Now the next all this will be comes under the IR region. All will be comes under the IR region. Clear? This in this manner you can calculate. Sir, I am in class 10th. Okay, if you are in the class 10th, now be prepared for the upcoming class 11th. So it will become a revision for you in your class 11th. Okay. Right. Okay. Now, if suppose if they ask how many total lines, if they ask, now how many lines, total number of lines if they ask, if the electron is coming from n is equal to n is equal to higher orbit, some n is equal to higher orbit, to n is equal to 1. N is equal to 1 means ground state. So the total number of lines formula we are having n into n minus 1 by 2. This is the one formula we are having, n into n minus 1 by 2. Clear? Next one. If suppose, if from the electron, if it is coming from n is equal to higher orbit, and it is not, n is not equal to 1. When it is coming from the higher orbit to n is not equal to 1. N is not equal to 1 means it should not fall in the ground state. Then the total number of lines if they ask, then for that one the formula we are having delta n into delta n plus 1 by 2. Delta n into delta n plus 1 by 2. Here the delta n is nothing but n2 minus n1. Higher energy orbit minus lower energy orbit. Clear? Now you say me, I will ask you one question. Now you have to say me the answer. Okay? If electron is present in n is equal to 6 level, coming to ground state, total possible lines are semi total possible lines are 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 15, 21. Sir, I want to do engineering, but I'm 15. Answer is 15. Amma, Sai Joshita, Joshita, once you cross check, actually this is 15 answer. Good, Subhana, good. We know, right? N into n minus 1 by 2, na? N is here, the n is higher energy level. Higher energy level. Higher energy level means here the higher energy level 6, right? 6 minus 1 by 2. 6 into 5 by 2. It will 3, right? 3 into 5. 15 lines. No. How come? Only 15 lines. Good, good. Subhana and Akshara. Anime boy, good. And the rest other, anyone is in the live, try to give me the answer. Don't see the live simply. My dear friends who are in the live, try to give me the answer. Yes. Try to give me the answer so that I can give you the questions based on your mindset level also. Okay? Right. Now, next one. Next one, the next type of the question we are going to see. Now, next one. If a electron is in n is equal to if the electron is in 8th excited state, electron is in 8th excited state, coming to 4th excited state, coming to it is enough sigma collector. You can see it is more than enough for your 11th for your. Now actually I was started the 12th itself. For the 11th now itself I was started the lectures which you are going to see now. It is more than enough for your JEE. If you are preparing for JEE, or if you are preparing for the NEET, or if you are preparing for any state entrance exam, it is more than enough. Tejas Joshi 10. When it is coming, if the electron is in the 8th excited state coming to the 4th excited state, total number of lines, total number of lines, total number of lines. Now Tejas Joshi has said it as a 10. Now we'll see whether it is a 10 or not. Now we are having the formula delta n into delta n plus 1 by 2, right? Clear? Now here the delta n is nothing but n2 minus n1. Now the 8th excited state, 8th excited state is nothing but n2 is 9, and 4th excited state is nothing but n1 is 5. Clear? Now 9 minus 5 is 4. So 4 into 5 by 2. Here it will give 2. So the total number of lines are 10. No, total number of lines are 10. Total number of lines are 10. No, 10. 8th excited state. 8th excited state is nothing but 9. 4th excited state is nothing but 5. 4th excited state is nothing but 5. No, answer is 10. Answer is 10. Yes, good, Subhana, good. If you do not try to give the answer, whether it is a correct or whether it is a wrong. Now, if you are giving Sai Sri Nitya, good, Nana, good. Yes, 10 is only the answer. Now we know, right? This is n is equal to 1. N is equal to 1 means n is equal to 1. N is equal to 1 means ground state. N is equal to 1 means ground state. Now n is equal to 2 means first excited state, right? First excited state. Then n is equal to 3 means second excited state, right? Second excited state. So first excited state means n is equal to 2. Second excited state means n is equal to 3 means. Now fourth excited state means n is equal to 5, right? N is equal to 5. Yes, good. Good, Nana, good. Clear? Now, the next one. Now next one. The next question. The next question we are having the shortest wavelength of hydrogen atom. The shortest wavelength of hydrogen atom in Lyman series. In a Lyman series is lambda 1. Okay. The shortest wavelength of hydrogen atom in the Lyman series is lambda 1. The longest wavelength in Balmer series of He plus ion is చెప్పండి. The shortest wavelength of hydrogen atom in Lyman series is lambda 1. The longest wavelength in Balmer series of He plus ion is He plus ion is He plus ion. Should I give the options or will you try by your own? Should I give the options or will you try by your own? Should I give the options or will you try by your own? Should I give the options or will you try by your own? Options. Right. Okay, many of them are asking options. No. First one, 5 by 9 lambda 1. Second one, 9 by 5 lambda 1. Third option, 9 by 4 lambda 1. Fourth option, 9 by 6 lambda 1. Right. I gave the options. Now try. Now try the answer. Yes. I gave, Rhoda. You can try. I gave the options. You can try. Option number 4. Option number 3. Option number 4. Option number 3. Oh my god. No. No. Sir, no, I think. No, answer is not 3. Not answer is not 3. Not answer is not 3. Should I explain? Yes, good, Subhana, good. Answer is 2. Answer is 2. Right. I will explain. Right. I will explain. No, answer is 2. Answer is 2. I will explain. Listen. Now he is saying the shortest wavelength of Lyman. Shortest wavelength of Lyman is asking, right? Now you see, what is the meaning of the shortest wavelength of the Lyman? Shortest wavelength, good, Akshara, good. Now, shortest wavelength of the, see, energy is equal to Hc by lambda, right? If the energy is high, wavelength will be short. So the shortest wavelength of the Lyman, if it is asking, means N2 is infinity and N1 is 1. Shortest wavelength. Then he is asking next one, longest wavelength in the Balmer series of He plus he is asking. So the longest wavelength of Balmer series. Longest wavelength of the Balmer series will be, now you see, longest wavelength means energy difference will be less. Then it will be from the N2 will be equal to 3 and n1 will be equal to 2. Done. Here the lambda 1 already he has given. This lambda 1 is equal to wavelength 912 angstroms by hydrogen atom 1 by 1 minus 1 by infinity. Clear? It will be equal to lambda 1 will be equal to 912 angstroms for the hydrogen atom. Next he is asking for the lambda 2 for He atom, right? Lambda 2 is equal to 912 angstroms by He atom. So it is 4. Now it will be 1 by lower energy is 4 minus 1 by higher energy is 9, because 3 square 9, 2 square 4. Now if you calculate, now what you will get? 912 by here 9 minus 4, it will become 5 by 36 into 4. This 4 and 36 will be get cancelled and it will give you 9. So the lambda 2, how much we got? Lambda 2 is equal to 912 angstroms by 5 by 9, because this 9 it has went to the numerator. Then you divide the lambda 1 by lambda 2. Then you divide the lambda 1 by lambda 2. Lambda 1 and the lambda 2. Lambda 1 we are having the 912 angstroms by 912 angstroms by how much we are having here? 912 angstroms into 9 by 5 we are having, right? This 912 angstroms will get cancelled. Then here the lambda 1 by lambda 2 will be equal to 5 by 9. Then if you cross multiply, now lambda 2 will be equal to 9 lambda 1 by 5. 9 lambda 1 by 5. That's it. Is it clear? Is it clear? Or still you are having any confusion? Is it clear or still you are having any confusion? Is it clear or still you are having any confusion? Once more. Once more I have to explain, or should I give the one more question? One more question I was to give you. One more question I was to give you, or once again I was to explain? Semi elaboratedly. Anime boy, Vishnu, what do you want me to ask? Explain again. Explain ఏం లేదు నాన్న. ఇక్కడ చూడండి, షార్టెస్ట్ వేవ్ లెంత్ ఆఫ్ ద లైమన్ అంటే n2 is equal to infinity, n1 is equal to 1. ఇప్పుడు లాంగెస్ట్ వేవ్ లెంత్ ఆఫ్ బాంబర్ అంటే n2 is equal to 3, n1 is equal to 2. ఎట్లా? ఇక్కడ చూడు, ఎనర్జీ డిఫరెన్స్ డెల్టా E is equal to hc by lambda. ఇప్పుడు ఇక్కడ షార్టెస్ట్ వేవ్ లెంత్ అంటే ఎనర్జీ డిఫరెన్స్ ఎక్కువ ఉండాలి అని అర్థం. ఎనర్జీ డిఫరెన్స్ ఎప్పుడు ఎక్కువ ఉంటుంది? ఇప్పుడు E is equal to డెల్టా E is equal to E2 మైనస్ E1 అని తీసుకున్నాం అనుకో, n is equal to E2 హయ్యర్ ఎనర్జీ అనుకుంటే, హయ్యర్ ఎనర్జీలో ఎనర్జీ ఎంత? 0, ఇన్ఫినిటీ కదా. ఇన్ఫినిటీ మైనస్ ఆఫ్ లోవర్ ఎనర్జీలో ఎంత? జీరో. క్లియర్? నౌ E1 లో ఎంత? మైనస్ ఆఫ్ -13.6 అంటే రెండింటి మధ్యలో డిఫరెన్స్ ఎంత వచ్చింది? +13.6 కదా. అట్లా. క్లియర్? డన్. రైట్. ఇంకొక క్వశ్చన్ ఇస్తా, ట్రై టు సేమ్ ద ఆన్సర్. ఇంకొక క్వశ్చన్ ఇస్తా. నౌ ఇది కొంచెం కాంప్లికేటెడ్ అండ్ ట్రికీ, మంచిగా ఉంటుంది క్వశ్చన్. ట్రై టు సాల్వ్. ఏమంటున్నాడంటే క్యాలిక్యులేట్ ద వేవ్ లెంత్, calculate the wavelength emitted, calculate the wavelength emitted during, calculate the wavelength emitted during transition, calculate the wavelength emitted during transition of an electron in between two levels of Li plus 2 ion, Clear? whose sum is 4 and difference is whose sum is 4 and the difference is 2. ఇక్కడ n1 ఏంది n2 ఏంది ఇవ్వలేదు. he has not given which is n1 and which is n2. you have to calculate, you have to find from your end, you have to find which is the n1 and which is the n2, and he is asking the lambda, right? Now say me the answer. Options I will write. A is equal to 912 into 3/8 angstroms. B 912 into 9/8 angstroms. C is equal to 912 into 8/9 angstroms. D none of the above. D none of the above. D none of the above. Now చెప్పండి. Answer is A. How anime by what? Which is the n and which is the n1 and which is the n2? Can you say me which is the n1 and which is the n2? Hi Elia. Hi, good evening. Good evening. Which is the n1 and which is the n2? My dear friends, try to do it from your own. If you are not getting, I'm here to explain for you, but don't say it in the Google or somewhere. Don't say it in the Google or somewhere. I am here to help you. I am here to help you. Okay? If you don't know, you can ask me. I will explain. Sir, n1 is... n1 should be the lower energy. n2 should be the higher energy. My dear enemy boy. n1 is 1. n2 is 3. Should I explain? Right. Listen. What is asking? Calculate the wavelength emitted during the transition of an electron between two levels of Li plus 2 ion whose sum is 4 and difference is 2. Whose sum is 4 and the difference is 2 is asking, right? Now, here n1 plus n2 is equal to 4. Clear? And n1 minus n2 is equal to 2. Then if you cancel it out, or if you do the minus, it will become plus and it will become minus. Then if you do, you'll get the n1 is equal to, how much you'll get? n1 is equal to 1 and n2 is equal to how much you'll get? 3 you'll get. Then if you calculate, you'll get the answer. If you get the answer, sorry. Now n1 plus n2 is equal to how much you got? 4 and difference n2 minus n1 is equal to 2. n2 minus n1 is equal to 2. If you do, you'll get the answer. Is it clear? In this manner, if you do, you'll get the answer. Here the N1 get cancelled. Left over will be the 2N2 is equal to 6. N2 is equal to 3. N2 is equal to 3. Then after that, this N2 you take it and put it in the N1 plus N2 is equal to 4. Now N1 is equal to 3, 6. Sorry. Now plus 3 is equal to 4. Now N1 is equal to 1. Is it clear? Yes. Good. Now the answer is A. 912 into 3 by 8 angstroms. 912 into 3 by 8 angstroms. Right. Now next we are going to see the drawbacks of the which one? Drawbacks of the Bohr's model. Now what are the drawbacks of the Bohr's model? Drawbacks of Bohr's model. Clear? Now the drawbacks of the Bohr's model. First one, he could not explain now why the electron revolves only in NH by 2 pi or H by 2 pi. Why the electron should revolve only in the H by 2 pi, he did not explain. Okay. Then second one, he did not explain about Zeeman effect and Stark effect. May I know what is the meaning of Zeeman effect and the Stark effect? Anyone? Can anyone say me what is the meaning of Zeeman effect and the Stark effect? Can anyone say me what is the meaning of Zeeman effect and the Stark effect? Can anyone say me what is the meaning of Zeeman effect and Stark effect? Can anyone say me the Zeeman effect and the Stark effect? Can anyone? What is the meaning of Zeeman effect and the Stark effect? Spectral lines emitted or radiation. No. What is the meaning of the Zeeman effect and what is the meaning of Stark effect? What is the meaning of the Zeeman effect and what is the meaning of Stark effect? Zeeman effect means definition. I'm asking definition. Zeeman effect and the Stark effect. A splitting of spectral line in the presence of magnetic field is called Zeeman effect. Good, Yashwant, good. Now the splitting of spectral lines, Zeeman effect means spectral lines splitting in a which one? Magnetic field. Good. Akshara, good. Oh, next Zeeman effect, and this is a Stark effect. Stark effect is nothing but in a electric field. In the electric field, it is splitting means Stark effect. In the In the magnetic field, if it is splitting means that is a Zeeman effect. Yes, good. Right. Now we'll see dual nature of the matter or dual nature of the electron. Now after these drawbacks, now we are going to see the dual nature of matter, dual nature of the matter or the dual nature of the electron. Now, wow, the dual nature of the electron we are going to see our de Broglie wavelength we are going to see. Here there was a scientist, what he has performed the one experiment, that it is how he has performed the one experiment by passing the one electron beam to the one gold plate. One gold plate, he has sent the electron beam to the gold plate, then exactly backward to it, he has kept a one diffraction grating. Now what is the meaning of, yes, double slit experiments, yes, good. Now diffraction grating, this diffraction grating when he has did this diffraction grating, he has observed the one diffraction patterns in this manner. Diffraction patterns. Okay. Now these diffraction patterns are the phenomena of the wave. This diffraction pattern. This is the diffraction pattern. These diffraction patterns are the phenomena of the wave. Then he has concluded that the electron does not moving in the fixed circular orbit, it is moving like a wave. Then he has concluded that electron is having wave character or wave nature. In the orbit it is moving like a wave. In the orbit it is moving like a wave. Clear? Now for that one he has given a one formula, one beautiful formula, that a beautiful formula he has given, that is, here he has considered that electron, if it is revolving in the orbit, if it is revolving in the orbit, then if this orbit number is equal to 3, then in the number of waves, if the electron, if it is present here, in the 3 waves it will complete its one revolution. This is 1, this is 2, clear, and this is 3. In the 3 revolutions, now the electron is completing its travel. In the 3 revolutions in this orbit, it is completing its revolution. I Vishal Raj, I. Then he has given a one formula, that electron is revolving like a wave and it is completing its one revolution, that is equal to 2 pi r is equal to n lambda. 2 pi r is equal to n lambda. This is a wavelength. And n is a number of waves made in orbit. Sir, if the number of orbit 1, then how the waves looks like? But it is very contradictory to show the one wave in the orbit. It is a 3D, like 3D in the 2D to define it is very much difficult. So from the 2, 3 we can show. In the 1D we cannot show. 1D, now how it is completing the 3D molecule showing in the 2D for the first orbit, it will make somewhat difficult. Okay. Now here 2 pi r is equal to n lambda. Then if we consider n is equal to n lambda by 2 pi. Now r is equal to n lambda by 2 pi. Then the Bohr orbit we are having mvr is equal to nh by 2 pi. mvr is equal to nh by 2 pi. Just now we got the r is equal to n lambda by 2 pi. Then mv is equal to n lambda by 2 pi is equal to nh by 2 pi. Done? Clear? Now here the n get cancelled. 2 pi get cancelled. then the lambda is equal to h by mv. We got it as, now this is a one very important formula we got. Here the mass should be in the kg. Clear? Here the whatever the mass we are having. Now Joshita, the for the n is equal to 1 orbit showing the wave, it is difficult. So the 3D molecule making in the 1D or 2D, it will make difficult. Okay. Now, right. Next. Here, based on this one, and the next one formula we are having, lambda is equal to h by mv, and we know momentum is equal to m into v. So in this place of the momentum, can we write the h by p? Now kinetic energy is equal to half mv square. Then for our mathematical calculation purpose, what I was doing, mv square into m by m I was dividing. Though this one will become the half m square v square by m. Then this we can write it as a half 2m into mv square. Done. 2m mv square. Then if you send it the 2m to the left hand side, then mv square will become 2m kinetic energy. That square if you send it to the left hand side, mv is equal to under root 2m kinetic energy. Under root 2m kinetic energy. That if you go and substitute in the here mv, then the lambda is equal to h by under root 2m kinetic energy. This is also one important formula we are having. This is one important formula we are having. Okay. So these are the some very important formulas we are having. You have to be very careful with this type of the questions they are asking. Right now we'll do the some questions based on the de Broglie. Then after that we'll go to the Heisenberg uncertainty principle. Right now. Now the my question is de Broglie wavelength of electron. De Broglie wavelength of electron is in fifth orbit, is in fifth orbit or fifth Bohr orbit. Fifth Bohr orbit. Now what is the de Broglie wavelength? What is the de Broglie wavelength? Fifth Bohr orbit it is present. What is the de Broglie wavelength? If the de Broglie in the angstroms, you say me in the angstroms, consider 0.529 as a naught. Consider 0.529 as a naught. Consider 0.529 as a naught. Now say me the answer. The de Broglie wavelength of electron is in the fifth Bohr orbit. Now what is the wavelength? Should I give the options or will you try by your own? Should I give the options or will you try it by your own? Should I give the options or will you try it by your own? Should I give the options or will you try it by your own? 10 pi a naught a. B 8 pi a naught. This is A naught. This is A naught. C 6 pi A naught. 7. Sorry. D 12 pi A naught. Okay, okay. I provided the options. I gave the options. You can see. Ten pi A naught. Good, good, good. Akshara, good. Answer is 10 pi A naught. Beautiful BPC people are responding very fastly. I need the response from the MPC as well as MSET. Anime boy, may I know from which stream you are? JEE mains or MSET? Vishnu, good, good. A option, right. We know 2 pi r is equal to n lambda. Then r 2 pi r radius of an Bohr orbit formula is equal to 0.529. He has taken as A naught, right? Then n square by z A naught. N square by z. Good, Nana, good. Good, H1, good. Then here, then I can calculate. Then I substitute here the n square by z A naught is equal to n lambda. Oh, Janakiram, Nuvena. Okay, okay, good, good, Janakiram, good. Right, right. Now here the n and the square will be get cancelled. Okay, Janakiram, okay, okay. Hydrogen atom, it is 1. So 2 into pi, which orbit is saying? Fifth orbit, right? Fifth, A naught is equal to lambda. So 10 pi A naught. 10 pi A naught is equal to lambda. Okay. Now we'll do another model of the question based on this one. Another model of the question. Right. If the lambda of nth orbit, if the lambda of nth orbit in hydrogen atom is equal to is equal to is equal to 3 pi angstroms, is equal to 3 pi angstroms, 3 pi angstroms. What is the value of n by z? 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 Now for this one, I will not provide the options. Try to do the question. For this one, I will not provide the options. Try to do the Siksa. Janakiram Siksa. Cheetah's developer. Hello, hello, hello. 6 by 1, sir. No. He's asking n by z. Ah. But how you got the answer? Once you cross check, Janagram, once you cross check the answer once again, once you cross check, anyone, Any answer from 3 by 2? Answer is 3 by 2. Good. Beautiful. BPC people are answering very fastly. Right. Answer is 3 by 2. Because we know 2 pi r is equal to n lambda. Already the wavelength they have given it as a 3 pi angstroms. Clear? 3 pi angstrom they have given. Done. Now here the 2 pi r is equal to n square by z is equal to n lambda. Now here the n one square will be get cancelled. If you send the 2 pi to the left hand side, now the n by z will be equal to 3 pi by 3 pi by 2 pi. Now the pi will get cancelled. Now the n by z will be the 3 by 2. 3 by 2. Yes, good. Now the beautiful BPC people are responding very fastly. Right. Good. Right. All right. Right. Now. Okay. Now, right. Is it clear? Are still will do the some questions? Still we do the questions? Now one question we'll do based on this one. Now right. One question we'll do. Yes, right. One question I will give you is the question is what is the ratio of the velocities? What is the ratio of the velocities of CH4 and O2 molecules? CH4 and O2 molecules so that they are associated with de Broglie waves of equal wavelength. De Broglie wave of equal wavelength. Of de Broglie of equal wavelength. Now say me the answers. Now say me the answers. Now options I will give you. A. Velocity of CH4 will be equal to 2 times of velocity of O2. Now B. Velocity of O2 is 5 times of velocity of CH4. C. Velocity of CH4 is 6 times of velocity of O2. D. Velocity of O2 is 10 times of velocity of CH4. Now which option is correct? Read the question carefully and try to give the answer. He is saying that so that they are associated with the de Broglie waves of equal wavelength. They are saying the equal. They are saying equal. Equal means for the CH4 and the O2, de Broglie wavelengths you make it as equal. Means de Broglie wavelength of CH4 equal to de Broglie wavelength of O2. That was I said you right. De Broglie wavelength of CH4 equal to de Broglie wavelength of O2. If you do, you will get the answer. Now try to do. de Broglie wavelength of CH4 equal to de Broglie wavelength of O2. Now solve the answer. C, I guess. No. No, Janakiram. No, no, no. No. What is the ratio of CH4 and the O2 molecule so that they are associated with the de Broglie waves of equal wavelength? Equal wavelength is saying. Should I solve? Should I solve? Should I solve the answer? Should I solve the answer? Right. Yes. Now you see. Here what he's saying the make it as the equal wavelength, right? Then lambda h by mass of CH4 into velocity of CH4 is equal to Planck's constant by mass of O2 into velocity of O2. Clear? Done. Then you take the which one? Velocity of CH4. Here the H get cancelled. And if you take the velocity of the CH4 to the right hand side, velocity of CH4 by velocity of O2 is equal to mass of O2 by mass of CH4. Done. Now we know the mass of O2 is 32 and the mass of CH4 is 14. Then mass of the CH4 is 16. Mass of the CH4 is 16. Clear? Now 16 by 32 by 16, it will give you the 2. Then velocity of CH4 will be equal to the 2 times of the velocity of the O2. Velocity of the CH4 molecule is the 2 times of the velocity of the O2 molecule. So the option number 1. Option number 1 is correct. Is it clear? Is it clear? Is it clear? Yes, yes. I hope it is clear. Right. Done? Now my dear friends, I was ending the live here. Now already it is 8:30. Now I was ending the live here. Tomorrow very important lecture I was going to start for you, that is quantum numbers, and the Monday's exam will be n number of questions will be from the quantum numbers itself. So tomorrow's live is very important, and the n number of the questions we are going to do, and the Sunday we are going to do the question session, so that it will be very practice for you for your Monday's exam. Okay, right. I was ending the live here, Nana. Now we'll see you tomorrow. Bye. Okay. Okay, I was ending the live here. Okay, sir. Right. Okay, we'll see you tomorrow. Bye.